In this video we're going to learn how to compute frequencies in SAS using SAS code. We're going to learn how to create one-way frequency tables and two-way frequency tables in datasets. So we're going to be working with the SAS help dataset birth weight. It's inside the SAS help library. As you can see, it has plenty of character variables. For example, this one, low birth weight, is a no yes type of variable. Married, which is this marriage status of the mother of the baby. Yes, no. This is this is whether the baby has low birth weight, age group, race, drinking status, etc. Right? So we may want to create a frequency table, let's say for low birth weight, to see how many or what percentage of the babies had low birth weight and what percentage doesn't, right? So a very simple way of doing this is through proc frequency, proc freq, okay, freq. So my data is basically SAS help dot birth weight. This is the way of saying that this data set inside the SAS help library. So we use the proc frequency, and the statement that we have to make is tables, and then you list the variables that you want to create frequency tables for. So if we run this, this is our output. We get the frequency of no low birth weight, yes, low birth weights, and then the frequency of married and not married and married mothers. We have the frequency, which is basically the count or the number of observations on each of these categories. We have the percentage, we have the cumulative frequency, and the cumulative percent. Now, usually cumulative frequency and cumulative percent are not interesting, and we just drop them from the table by adding this option after tables / no cumulative, no cum, right? So if you run that, you basically get the same tables without the cumulative frequencies and cumulative percentage. Now, also you could add an option to the proc frequency statement after data, is the order option, right? You could, which I think, okay, I already included here, order equals formatted. In this case, this means that I want my categories ordered by alphabetical order. So for example here, no goes before yes, because in alphabetical order N comes before Y, right? But sometimes you don't care about the alphabetical order, you care more about the frequencies. For example, you want from the largest to the smallest frequency, and that's when you do order equals freq, okay? Because you're gonna order the categories by frequency. So if we do that, I'm doing that just for age group, which is another variable here. There were 3 age groups. As you can see, they're scrambled. Why? Because we are reading this in descending order, right? So the one with the highest frequency, the highest percent, is group 2. Second is group 3, and then the one with the least number of observations is group 1, 10.25% of the observations, okay? Now, you could also want to get a two-way frequency table to see whether there is a relationship between two character variables. For example, you want to see whether there is some sort of relationship between low birth weight and whether the mother is single or not. So you can create a two-way table to analyze that, to see whether the percentages are the same or different. So this is the syntax, is with proc frequency again. But when after tables, in the table statement, you're gonna have the two variables that you're interested in creating a two-way frequency table for, and they're gonna be, between them you have a star. Okay, so that's the syntax. So when you run this, you get a two-way frequency table. You see, we in the columns we have married, in the rows we have the low birth weight. So here is basically the frequency or the total number of observations that are babies with no low birth weight and the mothers were not married. Now this is the number of babies who didn't have low birth weight and the mother was married. This is the number of babies that were low birth weight, mother is single, and this is the number of babies with low birth weight and the mothers were married. Okay, so we have the frequencies and then we have the percentage. So 61.25 were no, 61% were yes, no, 4.59% were no, yes, and 3.56 were yes, yes. And then we have the row percentage. So this is the percentage on this row, and we have the column percentage. So this is the percentage on this row. All of these things are related to the concepts of conditional probability and probability when you take statistics. So the two-way frequency table are very important for statistical analysis. Basically, we're trying to see whether there is the same incidence of low birth weight for married and unmarried females. So one way of testing that is through the so-called chi-squared test. Okay, so if you want to, and this is mainly for statistical purposes, for your statistic course. So if you want to see whether there is a relationship between these two variables, you request the chi-square test. And you do that by adding this option here to the table statement, / chi-square, right? When you do that, it will give you the same frequency, two-way frequency table, and then it will give you some statistics down here. Just look at this one, the chi-square. These are all basically alternatives to the chi-square test statistic, but this is the basic one. And this here is the so-called p-value. If that p-value is less than, let's say, 5%, that's kind of like the cutoff point in most cases for most research purposes. If this value is less than 5%, then yes, you can say, well, there is a relationship between these two variables, right? The incidence of low birth weight is not the same for married and unmarried females. And then, well, you can see that, for example, the incidence of yes, right, of low birth weight for married is, well, it's only 10%. Okay, so 10% of the married ones, of the married mothers, have low birth weight babies. And then 6.96 is the percentage of low birth weight babies for mothers who are single. So these two percentages, although they're close, they're not the same. Now, truly speaking, since the sample size here is huge, this, statistically speaking, this means nothing. But for a smaller sample size, perhaps this would indicate that, you know, there is a statistical difference between the percentages. But don't worry too much about that. You'll learn more about this particular test in your statistic course. This is just a way of looking at whether there is a relationship between two character variables, and I just wanted to include it because it's also explained in the book.